Okay, so another circuit that might come up is the microcontrollers. All right, we know them as the Genie chips. Occasionally in the exam, they get called PICs, peripheral interface controllers. Don't worry about that one. If it looks complicated, it's probably going to be a microcontroller. So, what is a microcontroller? Essentially, it's a computer in a chip. It responds to inputs. It controls output devices. It's easy to program. It's great for schools. And it can program using flowcharts or basic code. Facts. They run off 3 to 5.5 volts in DC current, direct current. They come in a range of packages in 18, 14, 8, 20, 28 and 40 pin sizes. Okay? And most importantly, they can actually pick up an analog signal from an LDR, a thermistor, and it can convert it into a digital value. So the higher the temperature goes, it will give it a numerical value which is digital. All right, they get called ADC, analog to digital converters. All right, and you recognise the package that they come in. So one of the questions might be, what are the advantages and disadvantages of using a microcontroller? Straight away there, it can do loads of things. On a normal circuit with 5 timers and 4017B decade counters and 7-segment drivers, there's loads of separate chips all doing lots of one individual thing. This one chip will do it all for you, and you can control it a lot more. You can also, if you make a slight problem error in your circuit, you can go into the software and the program and change it and make it work and make it a good value product without having to wipe out all of your circuit board. All right. They can be expensive. They can be fiddly. One of the disadvantages is they do need a separate download circuit, so you can actually plug it into the computer. But generally, they are very, very good. And as you know, a lot of you have used them for your coursework. They're really effective to do. So that's one question that might come up. Another question is, they might ask you to actually suggest a program. So I've got here a question from the 2016 exam paper, okay? And we're going to go through that now, making sure that we can cover and understand what each of those programming symbols are. They are standard, you can use them for anything. So we'll quickly go through what these are right now. You've got the start, it starts your program. If you haven't got one of these, stand up, walk out the exam and find a clip. Okay? Digital. Checks to see if an input signal has changed. Okay? And you can get it to say a question, has input 1 been turned on? Yes or no. Alright? Outputs, you're then able to control outputs. Okay? And you control whether an output is on or off. Okay? You can also change that to a tune, so you can send a specific tune out of there. I know the Simpsons theme tune can come out of that controller there, as long as you call it a tune. Wait, okay, you can add a wait of X number of seconds, or it could also be any instructions. For example, you could tell it it's going to count now. It's going to count how many times something in the program happens. And finally, stop. Go careful with this one. A lot of people put a stop right at the end because it sounds logical, but actually, if you get a program that goes to a stop, it will never start again until you take the battery out and put the battery back in. It's often better to just go back round to the start and then read the questions. The digital signal, has an input been turned on or off, is normally when something should start the program. So, here's the question. It's worth about 10 marks, this example. This question is about a microcontroller circuit for the garage alarm. So there you go, straight away you know you're going to be talking about microcontrollers. A system diagram, inputs, processes, outputs, okay, is shown below. It's easy. It even says the word outputs. It's got the process. Switches, we all know, most of us, okay, that those are inputs. All right? And it tells you what they all do. So, what it's asking for you to do, in the space below, use a programming system to write a program. So, and you need to read this carefully because it will change every exam, so that when first switched on, there is a 3-second delay. That'll be a wait. If either of the tilt switches senses movement, the light and sound outputs switch on for 60 seconds. So we've talked about the inputs, the outputs, and there's another wait. The sound then switches off, but the light stays on. Okay? So we're going to go through that now on the board, okay, and we'll go through how I would do that. All right? So we're going to start, and I'll try and do the colours. We're going to start with the start sign. Make sure when you do this, you try and match the shapes as best you can. All right? I'm going to do that in black so you can read it. Alright, if you forget the start, yeah, I'm over here. Okay, if you forget the start, you've lost a point straight away. It's then asking you, because it's told you this in the almost story format, it's asking you straight away for a 3-second delay. So we're going to put the weight in, which is the rectangular box, and we're going to write weight 3s. So easy. It doesn't matter what you write in there as long as it clearly describes it, okay, and you've got the right shape. So I put a weight in there for 3 seconds. You could have said 3-second wait. That's fine. Most importantly, because it's a flow diagram, show the arrows. If you forget the arrows, again, walk out the door, find a cliff, close your eyes and hope for the best, okay? So it's then saying if either of the tilt switches senses movement, the light and the sound output switch on for 60 seconds. It doesn't matter which tilt switch has been triggered. So we're looking at inputs here. So we're going to look at the input and we're going to ask a question, okay? So we're going to go SW1 dash SW2 on, question mark. It is a question, all right? Arrow down. Now, because it's a question, there's going to be yes, no answer. So let's deal with yes. If they have been turned on, it's telling us, don't forget the yes, it's telling us what we need to do next. It says the light and sound output switch on for 60 seconds. So I'm going to go to outputs. Okay. So output 1 and 2 on. Okay. Nice and easy. Okay, what we're then going to do, they come on for 60 seconds. We've done weights, rectangular box, wait, 60 seconds, nice and easy. It's then saying the sound then switches off. Okay, easy way of doing this is now just saying output 1 off, 2 on. The examiner doesn't really know which one is which. You could label that over here, but you've shown most importantly that one input is staying on, the other one has gone off there, okay? And it stays on. And that's pretty much it. It's not asking you to do anything else, okay? It's not asking you to cancel it. It's not asking you to go, what happens when the motion stops? None of that. It's just going to stay on. And you're going to leave it at that point there, okay? What you've got to think about though, is we did up here, we did a question. You had the yes answer, so what is the no answer? The no answer, okay, can come back up to there, okay? And it'll just keep going around. So you press start, it goes to wait, okay? It goes to switch 1, switch 2 on. If the answer is yes and they're both on, or either on, okay, output 1 plus 2 on, wait for 60 seconds, output left or 2 on, okay? And that's it. Or if it's no, it just keeps going around until it meets the yes condition to that question and then goes down, okay? If you've got time, colour them in. Greens, purples, blues. If you have to do a stop sign, make that red as well, okay? And that's pretty much it. There are any number of ways of doing that program. I could do the same program again in a second and it will be completely different, but as long as you've definitely proven all these things, that's fine. If you're not sure that it's clear what these are, label it next to it, okay? So here, light and sound on. Here, sound off, light on. And here is S1 or S2 on. And that's how to write a program. Remember each of those shapes, okay? Make sure you understand that these are always inputs, those are the outputs, and you cannot go wrong. Just read the systems diagram, nice and easy. That's 7 marks. Good luck.